once again. We are now on session 4 of Unit 6. Now, as we said earlier from session 3 to session 4, we'll start with a continuous distribution. So what the first continuous distribution we are going to consider? That's a continuous uniform distribution. Yes, so under this, what we'll be looking forward to. By the end of this session, we should be looking forward to state the PDF. That's going to be a density function. In the discrete distribution, it is PMF, that is probability mass function. But in a continuous distribution, it is probability density function. That's why its term is as PDF of a continuous distribution, a continuous uniform distribution. Calculate the expectation and also the variance of this uniform distribution. Now, definition. The continuous uniform distribution is defined by spreading mass uniform over an interval. And this interval we call here is what we call a closed interval. Closed interval, AB. And its PDF, probability density function, is given by f of x at AB will be equal to 1 all over b minus a, where x belongs to the closed interval AB, 0 elsewhere. You get it? When it's 0, then it means that elsewhere. So please pay attention. There's one. The function is 1 over b minus a, where x belongs to the closed interval AB. An example. A point is chosen on the line segment with the interval 0, 30. 0, 30. We are to state the distribution of the point and use it to find the probability that the point fall between A, 20 and 30, and B, above 25. I hope it's clear. So look at the example or the solution too. Now, if x is a positive of the chosen point, then x is uniformly distribution with the PDF, or is uniform distribution with the PDF with x of x 0, 30. And of course, the distribution is 1 over b minus a. And since our closed interval is 0, 30, that the 0 being a and the 30 being b, then what we have here will be 1 over 30 minus 0. That gives us 1 over 30. I mean that x belongs to that closed interval 0, 30. That's we've stated the distribution. Now, finding the interval. The interval probability of the point falling between 10 and 20, not 20 and 30. As I said earlier. The probability is between 10 and 20. So what it means is that we are going to, since it's a PDF, it's a continuous distribution, then we apply integration. So now we are going to integrate the function 1 over 30 along the interval 0 to 20. 10 to 20. So integrating 10 to 20 of the function 1 over 30 with respect to dx. Of course, we're going to have 1 over 30 x, and putting in the interval 20 and as the upper limit and then 10 as the lower limit, we're going to have our final result to be 1 on 3. Final result to be 1 on 3. Perfect. Quite simple, right? With a continuous uniform distribution. Maybe we would like to. The B part of the example says above 25. 25 or more. Remember that the closed interval we are given is from 0 to 30. So if you are finding from above 25, we cannot exceed 30. So our highest point would have been 30. So here we are integrating from 25 to 30. That's the highest limit given. So above 25 will be from 25 to 30. So integrating from 25 to 30, the function 1 over 30 with respect to dx. Of course, we'll give us this, and substituting the limit, we're going to have 1 on 6. 1 on 6. Quite very simple. What about the mean and the variance of a continuous uniform distribution over the closed interval AB? It's also given very simple here. The expectation, that's the mean, is A plus B over 2. And the variance is A minus B all squared all over 12. So let's now deal with the same example and solve another example. That example 2, we refer to the example 1. If you have to calculate the variance and then the expectation, or the expectation and the variance, what will be the solution? Remember that our A for the closed interval is 0 and the B was 30. So finding the expectation, that's A plus B, that will be 0 plus 30 over 2. Simply give us 15. So our expectation, or the mean, is 15. By giving us the variance, that's B minus A squared. So we have 30 minus 0 all squared, giving us, divided by 12, will give us 75 as our answer, right? 75. Sure, that's very clear. Thank you very much for enjoying the video.